Hello and welcome. So this is a mini series about Java Reflection API where we want to build our common used libraries and see how they work under the hood. Last time we covered basics of Java Reflection API. We did inspection of classes, found fields, types and their values, and were able to use that information to generate a JSON string. While we have successfully implemented our basic JSON mapper, it's far from being perfect. There are many things that we could do still, actually in the reflection context. For example, handling arrays, handling nested objects, giving a user control to mark some fields to be ignored or renamed. And today, to keep things more interesting, let's focus on the annotation processing. Annotations are special metadata that we can attach to our classes, fields, methods that doesn't really impact the way the code runs. It provides additional information for other tools, like compilers, runtimes, and other libraries. For example, some annotations can be informative. We can mark methods as deprecated, signaling user that this method should not longer be used. Some annotations could indicate for a compiler to do some actions. For example, an @override annotation that will check if the method actually exists that we are trying to override. These tools then can inspect our classes and perform some actions, either during compile time or during the runtime. For example, Hibernate Validator could pick up and scan our fields for annotations and perform validations based on the configuration. So let's catch up where we left off. We defined a method to JSON that accepts any generic object, and using Reflection API, we have extracted a class of it, we extracted the fields, iterated over all the fields, extracted name and value. Using that information, we outputted all the key value pairs in a JSON string. But of course, there are cases that we would like to keep some information secret. We would like to rename some fields. We would like to hide some things or do some manipulations before sending back. And it means us as a framework owners, we would like to have this power for the user to manipulate or interact with it in some form. Usually it is done with some heavy configs, but we are already used that many functionalities are handled by annotations, that we mark some field, method, class with an annotation and we enable specific functionality by doing that. And that is what we would like to implement. I would like to give a user an option to ignore some fields using a JsonIgnore annotation. Let's start by creating a package where we'll hold our annotations. And inside our package, we will create our first annotation. We will call it JsonIgnore, and we define it similarly to a class, to an interface with specific keyword called @interface. And if we select from the dropdown, we can see it here. So by default, annotations will not be present in the output of the compiled code. So we need to mark them as with special policy to keep them at runtime so we can process them at runtime. To do that, we here put a retention policy called runtime. Now we have defined our first annotation and we would like to process it. But in this mini series, we try to first follow the TDD approach, that we define a requirement as a test before implementing anything. We will define expected behavior for this annotation. As last time mentioned, I prefer to have a free section test. Given section, where we define our initial state or the input for our test. When section, where we perform an action and collect the results. Ending with then section, where we do verifications, assertions, and cleanup. In this case, we would like to have in given section some structure that has a field marked as JsonIgnore. We would like to have some title and, for example, author. And for some reason, we want to mark this author to be ignored. Now we create an input from it. So new book called Java Reflection 101 and author address. When collecting result as actual mapper to JSON and passing the input. Ending with then section where we define our expected value. In this case, it would be a JSON string holding title Java Reflection 101, and that's all. We should not include the author in the output. And then we perform the assertion. Assert equals expected and actual. For simple debugging, we could actually output the actual value so we see what is being generated. Let's run the test and confirm that it's failing. And we can see indeed test is failing. We expect to receive a JSON without the author, but author is present in the actual. So now that we have a failing test that confirms our behavior, let's get back to the implementation. Okay, now we need to find a way how we can check for the presence of an annotation. And last time when we scroll to the methods that are present in different objects that are returned by the reflection, I think you might remember that there was something related to the annotations. So we could read not only the fields or methods, but also annotations that are present. Let's see if this field has something annotation related, and indeed it has same function is annotation present. Now let's define a helper function that will check and tell us should we ignore this particular field, and all it will do, it will ask if there is annotation present with JsonIgnore class. Now going back up, we can use this function to exclude our fields. And as we are processing the streams, there is one handy method that we could to remove some of the elements from the stream called filter. So let's, before the mapping, call filter and check if this field should be ignored, but in the reverse order. So should this field not be ignored? Then we keep it and have it in our processing. Now that we have implemented it, let's run the tests. And you can see all of the tests are green, meaning we have not broken any previous implementations. And if we check our specific case, we can see indeed that we have excluded the author from the output. By introducing these annotations, we have now created a way for user to interact with our framework without modifying the code. He needs just to add this annotation to its own code and we will handle it. One thing that we need to keep in mind is the annotation target that we expect to be used. So currently, if we put this annotation on the class, nothing will happen. So for example, I can put a JsonIgnore annotation on itself, right? We know that we are only planning to use this JsonIgnore to be used on the fields. So let's restrict the usage and set it on the field level. And for that purpose, there is an annotation called target, where we can provide an element type, and we can see we have different element types that we can use, package, local, method, but we are interested in field. As soon as we selected the field, the JsonIgnore become red, and it is not allowing us and will fail with the compilation error. You can see in the test everything is okay because we have applied it on field level, but if I would provide it on method level, it would warn me with the compilation error. So let's do one more exercise. Sometimes we do not really want to expose the naming in the way that they are defined in our classes. They could be some technical namings, or they could be misleading. So we would like to provide the user a possibility to change the name of the field in the output. For that, let's define a new annotation called JsonProperty. We would also want that there is a retention policy of runtime, so it's not being erased. And we know that we would like to apply it only currently on fields. So we have now a new annotation that we can apply to fields, but on its own it will not do anything. And even more, there is no way currently how we can provide something to the annotation. Like here in this same example, when we're using the target annotation, we provide an element type. When we provide a retention annotation, we provide the retention policy. So we would like to also define some sort of way how we can pass some configuration to this annotation. If we open this annotation, we can see that it's not far away from our implementation. It also has a retention annotation on it. It also has a target, but a bit different, that it can be applied only on other annotations. So this interface has one abstract method called value that will return an array of element type. So following the same logic, we should be able to define similar abstract method. But we are interested in string type and value. It is time to define our requirement as a test. Let's define a record which will be used for applying our annotation. For example, let's again define book, and let's have title and some page statistics, for example, page views. The page views is quite technical name, so we would like to output it just views. Let's for that use our new JSON property and provide name views. So now let's create input, new book, provide title, Java, and we have some views. Following when section, where we gather our actual response from the mapper. Ending with then section, where we define the expected case. In our case, it would be title Java. And instead of page views, it should be just views and our number. And assertions assert equals. Let's run the test to confirm that it's failing. And indeed, we see that by default, it is not renaming anything. So let's head into the implementation and add this functionality. We have similarly defined a method getValue that is handling somehow specifically the field. In one case, it is quoting it. In case of numbers, it's leaving as it is. We could also define another helper function that would extract the name. So method that would return a string getName, provided we give a field that we want to use. So by default, we would like to fall back to the field's name, as it means that there is no annotation present, we return as it is. So if field is annotation present JsonProperty, then it means we have applied this annotation and most likely want to rename the field. We are not only interested in checking if the annotation is present, we also need to extract the data from this annotation. And we already saw that there are many methods to interact with annotations. Let's see if anything can be used. Field dot that is get annotation by providing specific type. So it means we can here provide a JSON property class, meaning we are saying give me this annotation back. And we want to save it, annotation. We can see using the generics, this var is already a JSON property. It could find and cast successfully to the needed class. And we have defined there a method that will return a value. So it should also be present here. So here we could just return annotation get value. Looks good. Let's add it to the code. So here, instead of field getName, we call our new created function getName and provide field. If the annotation is present, we should use what's inside the annotation. If it is not present, then we should fall back to the default name. And to confirm this fallback, we actually have previous tests. And that's why TDD is really great tool for building slowly and step by step. Okay, let's rerun all the tests. And all of them are green. And let's see our JSON property case. And indeed, we have renamed our field into the views. So tests are green, and we can confirm that we have implemented our new features for our JSON mapper. In this short session, we saw how we can create our own annotations, how we can control where those can be applied, and how we can add parameters to it. Having these annotations, we saw how easily we can expand our code functionality, allowing users to interact with our framework without modifying our code. They just need to apply our annotations and we will do the magic. And I think let's stop here for today. Next time we will continue expanding on our JSON mapper. There are still some things that we need to handle, like nested objects, arrays, allowing users to do some processing before the output. So if you like what you see, please subscribe, leave a like, leave a comment. Your feedback is really appreciated here. Till next time.